everyone. Thanks for joining us for today's Build Summit. I'm Susan Devitt. I'm a solution engineer here at Snowflake's Industry Solution Team. We'll be talking today about a solution that we built to do medical image processing, and I'll be joined later by Karuna, who will actually tell us how it's all been built. First, I'll give a bit of an overview into the use case that we have, and I'll show you a demo of the application that we built using Streamlit. And then I'll turn things over to Karuna, where he'll talk through the technical architecture and then give a step-by-step guide into how we actually made this happen. So to start out, if we think about medical image processing, one of the use cases that we'd like to think about is actually how we can use AI to be able to improve decision-making to become a decision support tool for doctors. If we think about the case of pneumonia, obviously, pneumonia is something that is important all the time, but it certainly was especially critical during COVID. Actually deciding whether a patient has pneumonia or not could only be diagnosed by an X-ray. And that can be quite a subjective call. For instance, one radiologist might see an image and say that it, has pneumonia. Another one might see something slightly different and say that the patient doesn't. It also takes time, right? It takes time for a patient to actually get to a healthcare facility to get that image, and it takes time for the radiologist to be able to do that diagnosis. So here we have a art of the possible use case where we actually can use AI to classify images for pneumonia and then use that trained model in Snowflake to actually be able to build an application to do inference. So as we get new images, we can basically instantly classify those. And we'll talk more about actually how we made that happen using the PyTorch framework running in Snowpark container services, as well as our Streamlit application that we'll talk through. And with that, I'll just say where we're going today. So we'll first go through our medical imaging AI platform. So running in our container services, actually using GPUs. So that medical image use case, right, requires a lot of memory. It's not possible in most cases to do that on CPUs. And so here we use our new feature of Snowpark container services to actually train our models on GPU and build a secure sandbox to train our research or production models. And then the next thing we'll go through today is our rapid detection pneumonia application. And so we've built this out using Streamlit in Snowflake. It's deployed in Snowflake, and using the Snowpark model registry, we can actually easily call those trained models on new images that we have so that we can rapidly do inference within Snowflake. And Karuna will talk more about how we actually did that. But before we get going, let me just show you an example of what our application looks like. So I have this application deployed in Streamlit in Snowflake. This is an application built in Python. And here what we see is we are using that trained PyTorch model to be able to detect pneumonia. So I've got a series of images here, and you can see the diagnosis made by a radiologist and the diagnosis made by our model, or the prediction made by our model. And so we can see here that for a wide variety of images, our model is doing quite well, although there are some cases where maybe there's some disagreement. And so with that, I'll turn it over to Karuna to actually walk you through how we built this and how this was done.
Thanks, Susan, for setting the stage of image classification on Snowflake. What I'm about to show you is how do we take this and then build it all from scratch in Snowflake. For that, I need to show you the high-level flow of how all this works. The crux of all this is where the data is residing. So imagine you bring your image data set and then put it on Snowflake internal stage. And then now, with the new announcement on Snowpark Container Services, you have the ability to access GPUs or CPUs based on the workload you're doing. In this case, since we are doing an image-based classification model using PyTorch, which is a deep learning model, it is memory intensive, and I've used GPUs to go ahead and do this training. For that, first, I'm using a Snowpark container services using the base NVIDIA Rapids base image, mounting it with a Snowflake internal stage, then going ahead and building a PyTorch model from scratch, and finally taking the trained model and saving it into the Snowpark model registry, which is in public preview right now. Once the model has been registered, you have the ability to go and deploy it in any Snowflake environment. And once the model has been deployed, you can take that and build data apps, which is on Streamlit in Snowflake, and then start showing the predictions and the inference for your consumers. For you to know how to build this, first, let me give you a brief idea about what is Snowpark Container Services. It is a fully managed container service by Snowflake. And what it is, it's a Docker container with the image registry and a compute pool that is built into it. You have the ability to use a language of your choice and bring the hardware flexibility, which is either using CPUs or GPUs. And the Kubernetes-based clusters are being managed by Snowflake. You can thereafter take these data apps and also put it in the marketplace through native apps. Now, coming to the Snowflake model registry, which is purely built for the purpose of machine learning operations, which is the MLOps, to manage and deploy models that are natively within Snowflake. It is going by the preview of leveraging the scalability and secure deployment that Snowflake offers on all product features that is available. And it has a good combination with Snowpark Container Services by either taking the liberty of deploying the model in a warehouse, which is a CPU, or in a compute pool on Snowpark Container Services using either warehouse or either a CPU or a GPU. Here is the end-to-end flow of how this was all developed. The starting point for this is using an NVIDIA Rapids image. We take that Rapids image and try to push it to an image registry or an image repository in a Snowpark Container Services. Then you develop a specification file for the Docker container, how you create a Docker container, and where is the image being residing. And finally, you're mentioning what volume to mount coming from the internal stage. Once you have prepared the specification file, you take the compute pool that is available either through GPU or a CPU and attach it to the container. Voila, you now can create a Docker container using Snowflake. Once the Docker container is created, in this case, we are launching a Jupyter notebook as an endpoint. The reason is the data scientists love Jupyter notebook, and that's why I'm developing this whole model in Jupyter notebook. The whole idea is to train on GPU and then give you the flexibility of able to deploy it in either a warehouse, which is a CPU, or a compute pool, which is on Snowpark Container Services. What I'm about to show you is only how do you deploy in a warehouse so that any consumer in your enterprise can go and leverage this model and start using the model for their inference. To recap, what we are going to achieve by this is 4 salient steps. 1, how do you load the data, which is the images in this case? The second thing is, how do you train a model using PyTorch or any of those deep learning models on Snowpark Container Services using the power of GPUs? And once you have trained, you want the ability to go and deploy it anywhere you want. And using the compute power within Snowflake, you have the flexibility to deploy it either in a warehouse or in a GPU in compute pool. And take that model and then use it for inference in a data app, such as a Streamlit, which is on Snowflake hosted application. Next, I will show you a step-by-step guide of how to build this from scratch. Logging into Snowsite, you are pretty much enabled with this private preview feature on this Snowflake account. Once you have confirmed this private preview feature has been enabled, you go and create a database first dedicated for this use case. Then try to use the database and the schema for this whole exercise. The first things first is you need a placeholder to go put your image, which is the image repository that is called the PyTorch repo in this case. Once you have created the repo, it will generate a URL for you, which is nothing but a repository URL. You grab this, and then this is where all your images are going to be sitting. In order to keep it easy and not navigate through many screens, I'm going to show you all that in one single Google Docs. Like I said, you go and create a database and then create an image repository. And then from the image repository, you go and grab the URL that is tied to that repository. Within that, you also want to create an internal stage where you want to put your specification file. You might want to define a specification file, something like this. Here, I'm bringing the image coming from Rapids and then tagging that and then pushing it to the image repository that I created up above. I'm also mounting my internal stage by calling it workspace/stage. And then I'm making sure my internal stage is accessed through that root folder within the container. Once the specification file is created, make sure you save it as a .yml or YAML script. After the script has been created, you might want to push this whole file into the stage that you created above, which is a placeholder for you to store the image. Make sure the stage has that image file located and you're able to see it. Now, you have crossed two hurdles, which is to create the image and push it to the image repository. Second thing is you have created the YAML file and put it in the YAML stage. Now, next is you need to attach a resource. In this use case, I am using only a GPU3 instance, which is an A10G coming from NVIDIA. And I'm attaching an instance family of GPU3 to the compute pool I'm creating. And I'm giving it a name, PyTorch pool. And then I'm keeping the nodes as one-on-one to keep it simple. All of this is done on Snowsite. The next thing is, because you have created the image repository, you have pushed the image in the image repository, then you have pushed the specification file in the internal stage, and you have created the compute pool using GPU. Now you can go ahead and create the service within Snowflake. The simple command gives you a service in Snowflake. To make sure that the service is up and running after you have created the service, make sure you call this statement and pass the database schema and the service name you're trying to check if it is ready. If you see the status as ready, then you're good and all set to move ahead. If it says failed, you might want to check the log. The way you want to check the log is by issuing this command. Now, you're all set as long as the service is saying it is ready and you can access it. The way you access the public endpoint, which is what you have defined in the YAML file above, you have mentioned the endpoint to be accessed, and it is through port 8888. And this is the exact endpoint that will be available for you when you describe the service, and then it will generate a public endpoint for you, something like this. Grab that URL and then launch it on a new browser, and then it should ask you to authenticate, which is pretty much the same authentication that you use to log into the database. Once you have logged into the database, and since it is going to give you an endpoint with Jupyter Notebook as a launch endpoint, it will open up an endpoint, something like this. Here is where I've gone ahead and trained a model using PyTorch. You have the ability to go and create your own image and add all these pip installs at the time of launching the image. In this case, I'm just keeping it simple to go ahead and install all the libraries, before I start building the model. Some of the libraries that you want to make sure it is there, since you're building PyTorch, is make sure your PyTorch and Torch Vision libraries are available. And for you to use Snowpark, you need to have this library, Snowflake, Snowpark, Python for pandas. And for model registry to work, you need to have this installed on this container services. Then I go ahead and import all the libraries that are required. I'm using Torch Loader to go ahead and read the images. First things first, I want to make sure that I have a CUDA device installed in this device, in this container services. So I'm assigning CUDA as the default device. And if it is not available, I want you to use CPU. Since it has recognized it has a CUDA, it is assigning CUDA as the device. If you remember, we went ahead and mounted the stage on the Snowflake container services. And this is exactly what we are saying. We are actually exploring if the data that we loaded in the internal stage is available. We're doing a simple list of the trained data set that is available and making sure the two folders or the two binary classes that we are determining today by training a model is either normal or pneumonia, and the image data set is there within that. You go ahead and assign the train folder, validation folder, and the test folder, and prefix it coming from the stage, which is here is an internal stage where all the image data set is sitting by each folder. Then I go ahead and do slight augmentation to the images and make sure that the images are all transformed in the same manner. I'm reading it through the Torch image loader and then making sure the transformation applies to all the training set, validation set, and test set. And finally, I'm using a batch size of 128 and making sure the data loader has all these three components arranged in a sequence. Now we go ahead and define the model parameters. Here, since I'm doing a transfer learning, I'm using a ResNet 18. I've also tested this model with BGG 16 or other pre-trained models. And I settled down with a ResNet 18. You have the liberty to change the transfer learning on pre-trained model at your convenience. Here is where I'm mentioning that I want to parallelize the nodes and I want to use all the 4 devices. If you see here, I'm using a GPU 3, which has 4 devices, and then I want to leverage all 4 to do parallel processing. Once you have defined the model parameters, you will get the blueprint of what the PyTorch model is going to do. Just make sure it is falling in alignment with what your thought process is and what you're trying to achieve. And I'm taking this model that I've defined above and assigning a loss function of cross entropy loss, and then assigning an alpha value of 0.001 and training for 20 epochs here. The 2 data sets I'm passing to the model is the train and the validation data set. I'm making sure the loss function is cross entropy loss, and then the device I'm passing is CUDA, and then the number of epochs is 20, and finally I'm getting a model out of it. The model will train parallelly across all 4 devices here. And then after the model has completed training across 20 epochs, it's going to say, I'm done with the training. Then you go and check the model training loss and then the validation accuracy compared to the training accuracy. If you're convinced the model is converged and you're quite happy with the model, then you go ahead and test it with the unseen data set, which is the test data set here. Try to apply the same transformation rules that you have defined above. Then once you have done that, call the model, then get the accuracy of what it is on unseen data set. It seems to be good. After you have completely satisfied and looking at the confusion matrix here, I see that the model is good at predicting pneumonia as pneumonia, and then the model is slightly struggling to call a normal image as pneumonia. I save the trained model, and then I make sure the model is saved locally in the Docker container. Now, the activity to go and train the PyTorch model on a Snowpark container service is completely done. Now we'll move on to how do we deploy this, log the model and deploy the model in Snowflake. First, you need to connect to Snowflake. To connect to Snowflake, some of the libraries that we imported above is necessary. Once you have connected to Snowflake, the parameters that you need is all provided by these credentials right here. In this credential dcr.json is where I am passing all my users, password, and then the role and the database and schema I need to be connecting to. After you have connected to the Snowflake account, you're going to confirm the parameters that you passed aligns with it, and it will display the message that it is connected. Once you're connected, now we want to go and log the model in the Snowflake model registry. Get the database and schema to which your Snowpark session has been assigned. Then you're going to give a name to the model name. And then the version is assigned above, which is version 25. Now we are accessing a registry, which is the model registry, by connecting to the session, the database name, and the schema, and make sure the registry is accessible. After the registry has been created, we want to log the model. Remember, you trained the model in a GPU, and we are trying to register this model in Snowflake as a CPU, which is on a warehouse. And also, since we used all the 4 devices, you may not be able to directly use the model. You might have to do model.module.to and then say CPU, because you're translating that model from a GPU version to a CPU version here. Then you pass the sample data, which is here. I'm passing a sample data from the validation data set. Once the log happens, it is going to generate a lot of metadata tables, and then it is going to make sure that the system registry is all intact. And finally, it will spit out a message saying the model has been registered with this cookie ID. To make sure the model has been registered, you can also access one of the metadata tables above that we registered, and then go and access the metadata table and then find out the model has been registered. And then there is a version number, and this is the model I registered. Once you have logged the model, you take that model that you have logged right here, and then you go and issue a new deployment name and call the model reference object using the registry. And then finally you say, I'm going to deploy this, and then target method is forward. Once the deployment is completed, what it is going to do is it's going to say that I have deployed this model in the warehouse. What it means is you are good to use this deployed model using a virtual warehouse, which is on Snowflake, by calling the predict function. In the SAS app, I'll show you how to use that. This is the SAS app that was built specifically to do the inference using the warehouse on the deployed model on Snowflake registry. Now I'm clicking that Streamlit in Snowflake app. Now it is warming up. Once it has connected to the server, it's going to open up the UI with which it was built. I guess you remember from what Susan was showing how the inference was done. Let me show you the backbone behind it. Like any other coding environment, Streamlit in Snowflake allows you to import any Python packages and then define all the functions. And then finally, you're able to also define procedures and UDF at your will. But that is not the intent. The intent here is how do we use the Snowflake model registry that we have registered without having to build an explicit UDF, whether it's vectorized or scalar. How do we go and do the prediction? The primary role is you connect to the same model registry. Once you have connected to the model registry, it allows you to take the model reference and then you do a model ref.predict and pass the exact deployment name that we used in the previous exercise, and then pass the new data, which is the new set of images, and then you should be able to see the output from that. Now, this will do some kind of pre-processing and also call this model object from the Snowflake model registry, and finally give you the inference on the images that you're calling here. And then you hit a run inference, then it'll run the inference on the images that are available in the Snowflake stage, and then get you the predictions for the image. With that, my demo for this show is completed, and I'll turn it over to Susan.
All right, thanks, Karuna. So for anybody who has questions about what was built today, we hope you learned a lot and got a taste of what it's like to build an application in Snowflake to do medical image processing and use Snowpark container services. Karuna has a blog post on Medium that has a lot of examples that he ran through today. And we also have a partner, Hakoda, who also has a blog post and can actually talk about doing implementations for these types of models in Snowpark container services. And as always, if you're interested in hearing more from Karuna and from the team that built this application, reach out to your Snowflake account team. Thanks so much. Happy building.
Hi, my name is John Osborne. I'm the field CTO at Ascend.io. We are an end-to-end pipeline automation software company, and we want to show you how to leverage our platform to use Document AI in this 2-minute builder video. The question we're trying to answer is, if I'm a bank offering mortgages, which buyers of properties have previously purchased a mortgage with us? This means that we're going to be ingesting PDF documents. We're going to use this brand new private preview document AI function that Snowflake provides. And then we're going to use some other Snowflake downstream technology to flatten that data, which comes out as JSON, and combine it with some master data. So if we're ingesting a PDF that looks like this, it might have some buyer names in it that are interesting. It's got a whole bunch of other fields, but we're going to use Document AI to pull data out of this document. How this works in Ascend is we're going to ingest the data, and then we're actually going to call the Document AI function as some SQL statement here. Here's the document extract features function, and we're going to ask questions like what's the MLS number and who are the buyers, and we're going to assign some fields for those. The outcome of that is two things. One is the URL, obviously, but then the second thing is the JSON, which is fully complete, but also problematic because it is not relational data. So then we move downstream and we use Snowpark and SnowSQL out of the box. I happen to use Snowpark for this demo, where we're going to flatten that data into using some table functions. We're going to flatten it into a better data set that's more useful to us in a relational environment. And here's some of the data. So I have a bunch of buyer names, some LMLS numbers, and some other data tied to documents. From there, I can ingest customer master from an ERP system or some other upstream customer data, and I can combine that to answer two of our two business questions. One is who is submitting a mortgage app that we know about, and who are my new buyers who I may want to do some marketing or better pricing for. I hope you enjoyed this real quick builder video. We appreciate Snowflake's environment, and I hope you check out ascend.io. Thank you.